My name is Eden, and today I'm going to be introducing our data sets. Our primary data set is from the Global Burden of Disease Study 2010 mortality results from 1970 to 2010. The time period covered in our data set is from January 1970 to December 2010. The Global Burden of Disease Collaborative Network is the contributor to this dataset. It was published by the Institute for Health Metrics and Evaluation in the year 2012. This dataset provides the number of deaths and mortality rates for 187 countries and 21 regions by age group and sex. Our supplemental data set is countries' GDP from 1960 to 2020. This data set is a subset of data obtained from World Bank National Accounts data and OECD National Accounts data files. It contains country names, country codes, and GDP for years from 1960 to 2020 as annual gross domestic income in US dollars for that year. Our primary dataset contains 7 columns. The first one is going to be our country code, which is the ISO code representing each country. Then we have country name, and then year, which will be data ranging from 1970 to 2010. For our fourth column, we have age group, which I will talk about in our next slide. For our fifth column, we have sex, which is the gender of the individuals, which will be male, female, or both. For our sixth column, we have number of deaths, which is the count of deaths for the specified age group, gender, and year. And for our seventh column, we have the death rate per 100,000 individuals in each of our specified groups. This slide explains all of our age groups that we have in our fourth column in the data set. As you can see, we have more specialized age groups such as 0 to 6 days, 7 to 27 days, and 28 to 364 days. These are age groups that tend to have higher mortality rates. So we included them in the data set to provide more specific and accurate data, and that helps give a better representation of our age groups and specific events that can happen at different times in your life. From the 1 to 4 years, each age group will increase by 5 years until 80 plus years, which will just all include anyone who's 80 or older. This slide shows 2 pie charts that explain the number of deaths by age groups in 1970 and then again in 2010. The pie chart in the top left corner is going to be the 1970 data. As we can see, the largest slice in the pie chart is going to be 11 million, and that's going to be for our 1 to 4 year age group. The second largest slice we have in the pie chart is going to be 10 million, which is our 28 to 364 days age group. On the other hand, in our 2010 data pie chart, you can see the largest slice is going to be that 24 million 80 plus years age group, and then we have the second largest slice being 11 million for the 75 to 79 year age group. This shows that within a short span of time, as a world, we were able to increase our technology and make medical advancements and increase our life expectancy as a population and increase the amount of people who are reaching those older years as compared to in the past when a lot of our younger population was dying.
We'll explore some critical questions that not only seek to understand the past and present trends of mortality, but also aim to derive actionable insights that can guide future policies and health interventions. Firstly, under trends over time, we'll examine the changes in mortality rates across different regions. It's important to consider both overall trends and specifies which age groups have seen most significant improvements in survival and what might be contributing to these changes. Moving on to demographic comparisons, we'll compare mortality rates between males and females across different age groups. This part of discussion will shed light on social and biological factors that might account disparities between genders and highlight which countries uh, exhibit the most significant disparities. In our geographical analysis, we aim to identify which regions of the world have experienced the highest mortality rates. Understanding the where is just as critical as understanding the why. As it points out towards areas that may require more focused healthcare resources or policy adjustments. Lastly, we'll explore the impact of GDP on mortality rates. It is crucial to discern whether economic prosperity translates to better health outcomes and how strong this correlation is across different time periods. In this section, we focus on the reasons why the study of mortality rates over the time across demographics is not just academic or but found of importance for practical applications. Let's start with temporal coverage. Our data set covers expansive 4 decade period, providing us with a longitudinal lens through which we can examine the evolution of mortality trends. This deep temporal insight is invaluable for identifying long term patterns and shifts in public health outcomes. It gives us a historical context necessary to understand where we are today and to focus where we might be heading. Next, we'll dive into demographical detail. The granularity of this data breaking down by age and sex equips with a powerful tool for detailed demographic analysis. It's the level of data detail that allows us to tailor health interventions and policy planning effectively. By understanding which segments of the population are most at risk or seeing improvements, we can better allocate resources and design target strategies. Lastly, the geographical detail. So our data set encompasses multiple countries, opening the door for the comparative studies that can inform us both health outcomes on a global scale. This comparative aspect allows us to learn the successes and challenges faced by different regions, forecasting the collaborative approach to global health issues. Here is the architecture of our project's data schema. We have synthesized a new measure by integrating mortality data with GDP values, addressing the gaps in our original data set. Specifically, we have incorporated a second data set for the countries that lacked GDP data. This schema forms a backbone of our project, enabling complex queries and comprehensive insights. Turning to our dataset visualizations, we employed various graphical tools to distill complex data into clear, accessible formats. Bar charts are utilized to illustrate trends over time in mortality rates, offering a straightforward comparison between different countries and genders. So, maps provided a geographical perspective, making regional differences immediately apparent and easy to grasp. Finally, we used tree maps and line charts to draw attention between GDP and mortality rates, capturing the economic dimensions of health outcomes. These visualizations are the key in making our data speak and allowing us to extract information, meaningful information, narratives from the numbers.
Yeah. Let's see trends over time. For trends over time, the first question is how the mortality rate changed over time in different regions. For this, we have used a column stacked column chart in Power BI with year in x-axis and death rate in y-axis. In this, we can see the group of 0 to 6 days and 60 to 64 years have higher death rate compared to middle-aged group. Overall, the height of the stacked column chart appears to decrease over time and suggesting a decrease in overall death rates among all the groups in different time periods. Yeah. In the first chart, we can see the mortality rate of all countries based on decades. In second chart, we can see the comparison between some of the countries, and we can see that Central African Republic had decreased and increased irrespective of the decades in the rates compared to other. Yeah. In third chart, we can see some other examples like Canada is decreasing steadily irrespective of the decade compared to others. Now let's see specific age groups where mortality has reduced more significantly than others. The chart in the left shows us the average death per 100K by year has declining steadily around 9.5K in 1970 to 5.5K in 2010. The right chart shows us that average death rate per 100K by age group. In this, we can see 0 to 6 days and 60 to 80 plus years age group have high average compared to others in the death rate.
Mortality rates can vary significantly between males and females across different age groups. So, understanding these variations through demographic analysis can provide insights into health disparities and potential areas for targeted interventions. So, when we talk about demographics, we have divided the population into smaller age groups through age and sex. In order to represent the same, we have created column charts using Power BI to analyze the mortality rates across different age groups. Talking about the male population and taking number of deaths onto the y-axis and age group onto the x-axis, we can see that the mortality rates have been largely different across the age groups. The least affected ones being the age group of 10 to 14 with the highest mortality rate. Children below this age and adults above this age are also widely affected. We can also observe the trend going up as the number of deaths increase as the age increases. People with the age of 80 or more suffer with the highest number of deaths, which means the lowest mortality rates. Talking about females, the trend has been quite similar to male population, but the key difference being the increased overall death across all age groups. There is a minimal difference in mortality rates in lower and middle age groups, but the number of deaths in females with the age of 80 or more are significantly higher than that of male population at a similar age. Generally speaking, on average, the mortality rates for males tend to be higher when compared to females across different age groups. Biological factors and occupational hazards could be some of the reasons why we observe these trends. Thank you.
For our geographic analysis, our question was what regions of the world have seen the greatest mortality rate? And we used the map visuals in Power BI to demonstrate what the data would look like if it was represented by the average death per 100,000 per country or by the total sum. The sum one gives us more obvious insight because you're going to have a higher death rate with the more populous country that you have. So these maps were preemptive in our analysis. The ones we made next are more insightful. We filtered by the max number of deaths per country in a given year. And throughout the decades, we can see that the countries that suffered the most mortality in the 1970s was shown to happen all over the world. And as we move through, especially through 2000, it got more concentrated in the underdeveloped or less developed regions of the world, specifically in Africa and areas near the Middle East. And then in 2010, it changed again. So you can see, so this would cause us to ask more questions about why did it not get more narrow and narrow. Kind of in 2010, it kind of got spread out again. That's something we would want to look into more. And our last question was the impact of GDP, and we wanted to know, can we correlate any significant changes in mortality rates with GDP during certain periods? And I'm going to add in certain countries. To get insights on this, we had to use another data set to bring in specific countries' GDPs in the years that matched up with the years from our original data set. And the new measure we used was an if calculate, and because some countries in the one data set didn't have data for countries in this one, I think it was like 187 countries and 120, so there was about 60 or so countries that didn't have any data for, so, but we still want to look into this. So then if we created a new column that had a yes or a no to see if the data set was located, if the country was on that other data set. And just as an example, we used Sweden and Uganda, and you can kind of see where the mortality rate, because most countries had a decrease in mortality, all countries had a slight decrease in mortality rate, but we can see the exact point of when GDP crossed over with the mortality rate. And we noticed throughout looking at different countries that the more developed countries, it happened earlier in time, whereas more countries that take longer to develop are still in the developmental process. The X was kind of more skewed to the right, as shown by Uganda. And another cool thing we were able to use was the tree graph, and there was certain filters where we could the big squares show the countries with the highest GDP, and then we can use a color gradient to represent, kind of see like where they fall with mortality rate. And I think it was like Pakistan is one that's dark blue. It had a high, one of the higher GDPs, but also had a high mortality rate. So that's something we could focus in on, and ask more questions about based on our initial analysis. And these are the references for our